Hey everybody, this is Nick Matthews. I'm a solutions architect here at AWS, and I work a lot with Cisco. So I'm going to kick this off. We're going to go through a couple agenda items here. So we'll talk a little bit about AWS networking, just a basic core level, and then from there we'll talk about some of the challenges that we see from networking in AWS, and from there kind of into the Cisco CSR overview, their use cases. And here are a couple of customer use cases from Under Armour and Adobe. And we're going to leave a pretty good amount of time at the end to do Q&A. So again, that Q&A panel is over to your right. Pop questions in there, and we'll go through that. And I'll go ahead and preempt the most popular question we get, which is, will the slides be available? And the answer is yes. After the webinar, you will get the slides. So we take a look at cloud in general. There's a lot of use cases for AWS. We just ended reInvent, which is our big customer conference last week, and there's tons and tons of slides online if you're curious about AWS. The keynotes are a really good place to start. But scalability, security, being able to be agile and experiment, use for only what you, or pay for only for what you use. The ability to go global in minutes. So if you're operating in a couple places, maybe in the United States, but decide your business wants to go international, AWS has 14 different regions. Almost every continent, so we can help you go global in minutes, right? It's pretty neat. As well, from a payment perspective, like I said, you pay for what you need. You can use auto scaling and a number of other types of features to actually reduce your overall spend. But the end of the day, none of that really matters because if your networking doesn't work. So the networking is the underlying aspect of every application, and if you guys are network engineers like me, you get to deal with that every day. So from the way that AWS networking works at a core level, there's a couple, maybe 4 major services we'll go over quickly here. So the first is Amazon VPC, or Amazon Virtual Private Cloud. So this is effectively our software-defined network that allows customers to operate on AWS. There's AWS Direct Connect, which is a service that allows you to directly connect in your existing network into AWS. The AWS Elastic Load Balancing, so that's basically the Amazon ELB, that's our load balancing option. And Amazon Route 53 is our managed DNS service. If we dig into VPC a little bit and we talk what the different layers look like, at a very high level, we've got regions. So like I said, we've got 14 regions. There's another 4 coming in the next year. And each of those regions are a set of data centers. So for us, each region is made up of at least 2 and usually 3 or more availability zones, or AZs. Those AZs are they're fault tolerant, so they have different power, different cooling. They have no shared fault segmentation. So if you run an application 2 different AZs, you're highly available. And so we've got 38 different availability zones across the world, and each one of those is actually often more than one data center itself. Your virtual private cloud, or your VPC, runs in a region, and that virtual private cloud this is where you put your subnets, your routing tables, your network ACLs, and security groups. So security groups are our sort of distributed layer 4 firewall. So that's a very high level of what we do from a networking perspective. VPC, if we dig in and out a little bit, it's the way that we do segmentation for networking. It effectively allows customers to deploy their own data center on AWS. So the VPC will allow you access to different distributed availability zones, so you can put in applications in a highly available manner. You can then start plugging in your on-premises data center via managed VPN, encryption. You can manage everything from the console or via CLI, so it's all API driven, and allows you to segment you may have different applications in different VPCs or different users in different VPCs. Sometimes people have a very large VPC and then use security groups to secure that within the VPC, but it's a network segmentation tool that customers can use. Direct Connect is a way for you to connect your existing network into AWS without having to use the public internet. So if you have a existing MPLS network or VPLS or IPVPN, you can do a network topology that makes AWS look like just another data center on your MPLS hub. Otherwise, some customers, they want to simply extend their AWS data center. This is often for when customers want to burst into AWS. They'll get something like a private line directly from one or more of their data centers to go directly into AWS over a point-to-point circuit. The benefits of it is one, you get the benefits of a private line. So from a security perspective, that's advantageous. As well, you get lower latency and more predictable packet loss and those kinds of things because you're able to have more control over the circuits that you run on. As well, there's also a cost advantage because the costing of the Direct Connect circuit is less than we charge for internet. So for high bandwidth, high throughput applications, it's often advantageous to use Direct Connect. Elastic load balancing is, it's similar to what you would see from a on-premise load balancer. We've made it a little bit more active for the cloud, so it does fault tolerance. It automatically handles multi-availability zone applications, so you can run one elastic load balancer that runs in all of your availability zones at once. If one fails, it handles that failover very well. And so then it also health checks your instances and interacts with things like auto-scaling so that if your application auto-scales, your load balancer auto-scales, so you don't have to re-architect any type of load balancing as your application scales up and down. And Route 53, like we mentioned earlier, is our managed DNS service. So if you want to manage your DNS load balancing between regions or within a region, or if you want to run private DNS within a VPC, if you want to do things like active passive failover or latency-based failover or geographic-based DNS routing, Route 53 is what you want to look at. So those are the kind of the core AWS networking features. And of course, there's always more advanced things you want to do with networking and networking services. So the AWS Marketplace is a place where you can go and look for the common third-party tools that you may use in your on-premise data center that you may want to bring into AWS. So this might be, as we've listed here, routing, VPN, application delivery and load balancing, or security and firewall tools. So from the AWS perspective, Cisco is a leader for us on providing these services in AWS. And this is a good time now to introduce Fan Yang from Cisco.
Hey guys, this is Fan Yang. I'm the technical marketing engineer working at Cisco. So today I'm going to talk a little bit about the network challenges in the cloud and how we solve it with the Cisco CSR 1000V router. So we have seen customers that moving their workload, their services from their on-premise data center into the cloud. And the most concern is about how do you secure the connection and how do you enable the security in the cloud and how do you do hybrid cloud. And Cisco has a lot of network applied on the on-premise side. So you have Cisco router, you have your Cisco switch, that's in your enterprise network. And at the other side, you have the public cloud. And public cloud, you have all the VPC or the Route 53 that Nick just mentioned. But how do you enable the hybrid cloud and extend your enterprise network into the cloud? So if you're looking at the physical side, Cisco physical routers, ASR 4K, ASR 1K that sit on your data center or sit on your branch offices. And we now offer the Cisco CSR 1000V, so it's a virtual router. It can run on the virtualized hypervisors like VMware, Hyper-V, and KVM. And also it can run on the public cloud like Amazon. And let's talk a little bit about what the virtual router can do and how the enterprise customer can leverage the virtual router in the public cloud. So CSR is just like the Cisco enterprise router, so we just virtualize the code and run it on the virtualized platform. So it has the same feature as the physical router, except some of the legacy features like ATM, like frame relay. I don't think any people will use that in the cloud, right? And the other part is this virtual router is very powerful, so you can reach from 10 megabit per second all the way to 10 gigabyte per second, depends on which instance you use, what's the CPU that you use for this virtual router. and it support from running as one-way CPU, two-way CPU, four-way CPU, and eight-way CPU. For the license part, we sell the CSR as a software, so you can use 1 year, 3 years, 5 years, or even using the already built license on the Amazon Cloud. So we recommend the customer to use the smart licensing to manage the CSR because it's a more efficient way to manage the software. And the CSR will give you the same console, so you will have the full CLI, SSH console into the router, and you can configure like the same router you configure on your on-premise side. And we also offer netconf YARN protocols to program the router as well as the RESTConf. So let's talk a little bit about the use cases and how customer can use CSR in the cloud. So on the upper side, you have your on-premise network, you have your branch, you have your data center, and in the Amazon, probably you will have VPCs. So the first use case is how do you secure the connection from your on-premise network into the cloud. So you can put a CSR in the VPC and you will establish the IPsec tunnel all the way back to your on-premise side and do the IPsec encryption. Since it's a Cisco router, so you can use any of the Cisco VPN technologies like DMVPN, FlexVPN, EasyVPN. So we support up to 1,000 tunnel on the CSR per instance. The second use case is if you have the remote workers that's on the way and they can use their laptop, they can use their mobile phone to use any Connect software to deal into the CSR and access the services in the cloud. The third use case is more like if you have multiple VPCs in the cloud and you can use CSR to connect those VPCs together and build a VPN overlay network. And last one is since it's a Cisco enterprise router, so it has all the enterprise features like firewall, like application visibility control. You can enable those features on this virtual router as well. Okay, and how you find the CSR, just go into the marketplace. It has been there for 3 years, so you just search Cisco and you'll find the Cisco CSR router listing there. And let's talk about a little bit about the Transit VPC we just launched with Amazon. So we see customers that will have multiple VPC in the cloud, they have their on-premise network, and they also probably will have other providers' network. And how do you connect those network together and build overlay network? That's the solution we're going to introduce in the next slide. So here we will create a dedicated Transit VPC. We will put 2 CSR that sit in different availability zone, so it will give you all the high availability and redundancy. And then you have your spoke VPC, so it could be your development VPC, production VPC, test VPC that across different region, that could be across different Amazon account. So those VPC, in those spoke VPC, you will use Amazon Virtual Private Gateway, so that's the VHW to build IPsec tunnel into the CSR, so they will exchange the routes based on the tunnel. And on the other side, there's your private data center, so probably you will have a Cisco physical router, and you can connect the physical router to the CSR through IPsec tunnel and run BGP over it, so they will exchange routes based on the protocols. Then those spoke VPC and on your on-premise network can talk to each other through the CSR, so that's what we call the Transit VPC. So this solution can be launched from the marketplace through a click, so it's launched through a CloudFormation template. And there will be a Lambda function that's running in background. It will check which spoke VPC you want to connect by a specific tag. So if you give that spoke VPC VHW a specific tag, the Lambda function will go into the CSR, push the configurations. So the tunnels will be built up and the connection will be set up automatically. So that's how the solution works, and you can find more on the marketplace with this solution. And how you purchase CSR, we offer two type of license. So you can use BYOL, so that's bring your own license. As I mentioned before, and also you can use hourly build license from Amazon. Okay, so that's pretty much of what I want to introduce today. So next I will hand it to Daniel Zuckerberg. So he's the customer solution architect at Cisco. He will talk about how Under Armour they're using CSR in the Amazon.
Thanks, Fan. And so as Fan explained, I'm a solutions architect at Cisco. I've been working with Under Armour for about 5 years now and partnering with them on some of their business challenges. And for those who don't know Under Armour, their business has been moving at the speed of light. They've expanded globally and they're constantly expanding into new markets. And this is really why cloud makes a lot of sense for them. It enables their business to be fast and really delivering services. And so I was just talking about how this has really driven the need for the IT team to evolve. And they've really been focused on being a service broker and really delivering IT as a service so they can best serve the different lines of business at Under Armour. And while at the same time they've really had a need to maintain visibility and maintain compliance within the organization. And that's where they've really looked towards the CSR platform as an enabler for bridging the cloud with their maintaining the compliance and visibility that they had on-prem. So when they looked at the cloud, there was really 3 aspects of it in terms of integrating it with their on-prem infrastructure. So primarily, or the first one was really time to market. So again, the cloud really enabled them to deliver services quicker and bring services to those different lines of businesses when they needed it. Well, at the same time, they really had to focus on minimizing the risk of putting services in the cloud and identifying ways in order to accomplish that. And lastly, how to improve aspects of quality of service. So a huge part of the organization is focused on user experience and ensuring that they can continue to drive increased productivity and deliver services when users need it. And so at the same time, one of their areas of alignment was around their WAN architecture. So when they were evaluating how to integrate the cloud into the organization, they were really focused on how they approach the WAN and how they design the WAN architecture so that they can integrate these users and focus on aspects of the user's experience, while at the same time maintaining compliance with their security policies and providing visibility to their operation teams. So the way in which they approached this was really focusing on Cisco's IWAN. So when you consider a traditional WAN approach, generally it's more of an active standby type of approach, and it includes complex redistribution and routing policy in order to leverage different circuits. So one of the benefits that IWAN brought to the Under Armour organization was that it allowed for active paths across both MPLS and Internet. And this held true as they were looking at integrating the cloud as well. So from a high level, Under Armour is organized with different points of presence across the globe. They've got a point of presence in the US, Latin America, EMEA, and Asia. And so this was part of their consideration as they were integrating cloud services in as well. How do they integrate a VPC into their overall WAN architecture? And so what they were able to do with the CSR was really continue to leverage the same policies that they were leveraging at the branch and be able to connect those VPCs similarly just like a remote branch office, and where they would leverage the DMVPN service and connect that back to one of their primary points of presence. So across the globe they can integrate cloud services from AWS into different points of presence they have distributed across the globe. And at the same time leveraging AWS Direct Connect to represent an MPLS connection, and as well as leveraging an internet circuit for failover of their WAN connectivity. And something that they were exploring as well is how they scale this architecture. Because ultimately they had different lines of businesses deploying services in different VPCs. And so as they were approaching this problem, they were looking for ways to make it more scalable and make it cost effective at the same time. So the way in which they did this was leveraging that Transit VPC design. This allowed them to have a single point of management for the networking while allowing different lines of businesses to control their application stack in each one of their VPCs. So they ultimately had control over all the ingress and egress traffic going in and out of VPC back to the enterprise. And that represents from a high level the CSR architecture and Transit VPC design that Under Armour integrated into their network. And so with that, I'm going to hand the ball to Carl Coles, who will discuss the Adobe CSR design.
Hi, thanks Daniel. Hi, my name is Carl Coles. I'm a principal network architect here at Adobe. And today we're going to cover how Adobe Marketing Cloud uses AWS and Cisco CSR 1000Vs to deliver rich digital experiences to our customers over multiple touch points around the world. Adobe Marketing Cloud is one of 3 business units within Adobe. It provides a comprehensive marketing solution, allowing marketers to be more effective at delivering the right content to the right channels to reach our customers. The Adobe Marketing Cloud enables marketers to measure, personalize, and optimize digital experiences. Marketers use digital body language to craft personalized campaigns. These campaigns are presented to the users in many different formats across multiple touch points, whether it's on an iPhone, an Android device, or a desktop, or delivered through email or even a commercial during the Super Bowl. Sorry guys, my slides weren't advancing. Reaching our customer base in a timely manner becomes more important as we size the digital experience, and it continues to expand on new platforms and formats. The speed to market requires more agility and mobility to deliver this user experience in more dynamic ways. This rapid pace to the market requires digital marketing developers to transition their workloads to a more agile public cloud provider like AWS. Using AWS tool sets streamlines the development lifecycle, and soon production workloads were soon to follow. These workloads were moving into AWS without much consideration around connectivity to private resources. Various solutions were used to solve the connectivity dilemma, like VPC peering within an AWS region and IPsec VPN tunnels to private data centers and corporate offices. There wasn't a centralized network solution that met the needs of every engagement. Regardless of this connectivity challenge, the adoption continued to increase on an as-per-account basis. Eventually, Adobe had over 700 AWS accounts across multiple regions. VPC scaling and VPC peering limitations and the management of those accounts relationships became a much larger burden as more teams required collaboration. And the security teams wanted to ensure our products were following security standards when delivering data across the public clouds. There became a more pressing need to deliver a global network connecting public clouds to private data centers. With this concern in mind, network engineering began to get more involved to deliver a solution to meet the needs of this complex connectivity. Luckily, our existing global network was already supporting architectures like AWS's VPCs, utilizing our MPLS VPNs across the Adobe Marketing Cloud. So over the next few slides, I will discuss how Adobe uses MPLS VPNs to build a seamless architecture with AWS and VPCs. So this slide is a brief introduction into our global network architecture, mostly from a high level, and how Adobe solutions are delivered. Adobe prides itself on ensuring the best customer experience by delivering personalized content to the end user within 300 milliseconds. That's a healthy goal given the compute and network resources required to stitch together that experience. These last milliseconds require our solution to be as close to the end user experience as possible. Our infrastructure design is based on and edge collection and core processing. This design allows us to accomplish this goal by extending our edge collection ever closer to the customer base. As our customer base continues to grow, we need to keep pace with more edge collection facilities. We support over 30 global locations, mostly edge collection services. Our edge collection facilities are a mix, some privately owned, and we have some public cloud offerings. As we start to expand our offerings into smaller regions around the world, we will leverage cloud edge collections like AWS due to the cost savings. Our core processing centers are regionally located and operate out of privately owned data centers around the globe. We utilize MPLS throughout our network whether it's for traffic engineering purposes to deliver inter-regional data center connectivity or to provide network segmentation between production and development environments around the globe. Our high-speed transport delivers highly available connectivity between our regional core processing centers and edge collection facilities. The Adobe Multi-Cloud Transport delivers a global MPLS network built on Cisco ASR routers. It connects mixed data center infrastructure together and allows applications to traverse end-to-end transparently. Utilizing overlay protocols for end-to-end delivery allows the data center infrastructure to remain independent and reduce the complexities of integrations of more specific technologies like IGPs and Layer 2 protocols. The Adobe Multi-Cloud Transport integrates private and public clouds using this overlay protocol. The multi-cloud transport network routing fabric contains 4 functional routers. The Edge Transport Router aggregates regional data centers and our transit backbone pipes. These are MPLS-P routers and advertise BGP VPNv4 routes to data center edge routers, and they are Cisco ASRs. Our data center edge routers are MPLS-P routers as well. They announce data center routes into the regional edge transport routers. These are Cisco ASRs in the private data center and Cisco CSR 1000Vs in AWS. Our data center PE routers are a mix of Cisco 7Ks, ASRs, and in AWS, it's a Cisco CSR 1000V. They terminate VPNv4 and VRF routing facing our customer edge routers. The customer edge is a combination of routers and switches. In our physical data centers, they are top-of-rack switches and core. In AWS, it's actually a virtual instance acting as a router running a BGP daemon. This was chosen instead of the CSR 1000V for automation and cost reasons. Using the Cisco ASR and CSR 1000V as MPLS routers supporting P and PE functions simplified our delivery of AWS VPCs. This allowed us to integrate public clouds while maintaining our architectural intent of east-west service delivery. The CSR 1000V is our primary edge solution when aggregating multiple AWS regions across our private backbone. Now within each AWS region, we have multiple accounts requiring collaboration across VPCs, and traditional VPC peering does not scale. To solve this scaling problem, we implemented a hub and spoke topology using Cisco CSR 1000V with GRE point-to-point tunnels and BGP peering across VPCs within a region. We call the hub VPC our regional core transport. It delivers in-region VPC to VPC communication across an overlay fabric of GRE point-to-point tunnels. The hub also delivers global connectivity to the region using AWS Direct Connect. As you can see in the diagram, we have customer edge routers connecting a spoke VPC to the hub VPC. The customer edge router is a virtual instance running CentOS and BGP, Bird BGP daemon. It is our integration point with the spoke VPCs. The customer edge not only auto-announces more specific subnets of the VPC to BGP peers in the hub, but it handles AZ failovers as well. The adoption of the CSR 1000V into our environment was seamless because it was a familiar platform. Its configurations is the same as our ASR 1K platforms. And we deployed a CSR 1000V in virtual infrastructures exactly how Cisco ASR 1Ks are deployed in physical data centers. It supports our global MPLS configuration, our routing protocols, BGP and ISIS, GRE tunneling, and our global zone-based firewall policies. Adobe chose to move to the bring your own license model, which provides vendor support using our existing SmartNet contract, as well as a reduction in the licensing costs over the pay-as-you-go model. Now let's get into the details of how to deliver VPC connectivity via this overlay solution. We use MPLS VPNs. We use the regional core transport, as you see in the blue there, as a Transit VPC. It houses our MPLS transit routers and management services to support an AWS region. We use MPLS VPNs on the PE routers to align with AWS VPC subnets to deliver an end-to-end transport. Okay, now let's focus on the diagram. The Cisco CSR 1000V Edge pairs with the Edge transport to deliver global connectivity to the region. It peers across a GRE tunnel that is established using AWS Direct Connect and AWS Virtual Private Gateways. The tunnel terminates on the Cisco CSR 1000V Edge across Direct Connect to the Edge transport. We create an underlay of reachability via the BGP peering that's established via Direct Connect into an isolated VRF on each router. Then we build our GRE tunnels over the isolated VRF. We use this tunnel to pass our regional MPLS VPN traffic. Inside the region, we have GRE point-to-point fabric built over AWS's virtual routing infrastructure. The GRE point-to-point fabric delivers data plane reachability across the entire region. We use BGP and ISIS routing protocols to deliver next-hop reachability over this GRE fabric and to our spoke VPCs. Deploying a Transit VPC as an AWS regional hub allowed us to create a centralized security choke point for traffic entering and exiting the region. The security team likes this advantage. They can enforce and monitor the universal security policy across multiple AWS regions. The customer edge router announces VPC subnets. It BGP peers with our CSR 1000V PE router into our VRF. This allows us to move to forward VPC segmentation across any given region, whether it's in AWS or our private data centers. The customer edge translates BGP routing updates into AWS API calls and updates the customer VPC routing tables with the correct next hop of the customer edge router for destination networks. This allows us to dynamically provide high availability across multiple AZs within a VPC. We use Terraform to automate deployments of this entire infrastructure. As we covered earlier, the Cisco CSR 1000V is a familiar platform to Adobe and seamlessly fits into our operational framework. It supports all of the same routing protocols and is fully capable of delivering our overlay transport connectivity between AWS and on-prem data centers. The Cisco CSR 1000V supports zone-based firewalls and MPLS, which allows Adobe to extend network segmentation across private and public clouds. As Adobe Marketing Cloud extends into more regions, utilizing AWS Public Cloud and the Cisco CSR 1000V will increase cost efficiencies while reducing total cost of ownership. Thank you. Now let's move on to Q&A.
Cool. All right, guys. So let's see. We've got a lot of questions here. I'll try to get through some of these. I think we've done a pretty good job of handling them most so far. There's still some questions coming in, so send the questions in as we're sitting here going through. We'll go through some more questions. So we'll talk about some of the questions that came in. A couple questions about China and the availability of CSR there. So it is available to China, and there is an email that you need to access to get permissions Fan or someone else, do you want to share that email real quick? And I may still be on mute.
Yeah.
I know one of the questions got answered around that.
Yeah. You want me to put the email on which window? Okay, yes.
I was just going to say maybe you can, it's in one of the questions, right? So people that are interested in that can go find it.
Yeah.
There's also a question about, that we went pretty fast through the AWS networking options. That's true. Yeah, this is mostly a Cisco webinar. If you're wanting to get more introduced to AWS networking basics, I would suggest doing a Google search for VPC for network engineers. There's a blog post out there, actually 2 of them, that go over the VPC fundamentals for network engineers in detail. There were some questions around SNMP monitoring, if that's supported in the CSR, that supported MPLS support. You can do MPLS on the CSR. There was a question if you have multiple VPCs, how do you connect them together? Do you have to get CSR in each one? And that's actually part of the entire Transit VPC architecture. So again, if you do a Google search for AWS Transit VPC, that's a solution that the AWS Solution Builders team built. Basically allows you to the main use case is around centralizing VPN and Direct Connect connectivity. From there, we have some Lambda automation. So if you add new tags to new VPCs, they'll automatically be added to the Transit VPC architecture. So there's some cool Lambda automation that we built with that we worked with Cisco on. So if you're wanting to connect multiple VPCs in multiple even regions, that's very cool. There was some questions around IWAN. What is Cisco, guys? Do you want to talk about the IWAN capabilities of the CSR?
Yeah. So I think if you are talking about IWAN, so CSR has full features as the ASR1K. So you can run VPN, you can run AVC features on Amazon. There's no problem supporting that. And our engineer team is working on the PFR, so we're trying to validate the performance of the PFR and see how much we can get for the PFR, performance routing, basically. Yeah, so IWAN is supported on Amazon, running with CSR.
Okay. There was a question around how do you secure your Direct Connect circuit. So, it's kind of a loaded question because security is always depending upon your individual business requirements. There's a couple different ways to look at that. One is if you use a private circuit, and if you trust that circuit, that's a lot more secure than the internet to begin with. If you don't trust that circuit, so if you want to make sure that you've got maybe encryption in transit from your data center or your users all the way to AWS to the instance that's going to be processing that traffic, possibly for HIPAA or financial regulations, then what some people will do is they will run a VPN over their Direct Connect circuit. So this is another use case for the CSR. So you would create a VPN from your on-premise device to a CSR in AWS. You can even use things like DMVPN if it's a multi-point VPN, and then you're running encryption. After you go through you may run into performance bottlenecks on a single instance. So at that point, this actually relates to a different question we got around, how do you scale this out? There's a number of ways to scale it out, but the easiest way is to create multiple CSRs and then use BGP or another routing protocol on top of that to distribute load, equal cost multipath and those kinds of things. So from a security perspective, you just encrypt over your links. That's the same thing you would do, for instance, if you wanted to connect regions. So there was a question about, if you've got multiple regions, how do you peer those together? So in AWS, there's a feature called VPC peering, which basically allows two VPCs to directly talk from instance to instance. If those two instances are in different regions, today you either have to do one of two things. You either need to create a Direct Connect circuit between those, which is fairly feasible if they're, for instance, in both the United States. But if one's in the United States and one's in Europe, you're probably not going to get a Direct Connect circuit over the ocean just for that. So in that case, you would want to use like a VPN option again with the CSR. So that's how you would do multi-region there. There was another question about the security controls. So if you want basically, can you access the CSR as a firewall? So the CSR does have the zone-based firewall on it. So those features allow you to do stateful security, all the zone-based firewall features that have been Cisco for quite a while. Otherwise, if you need more advanced firewall functionality, you may want to look at Cisco's other firewall options, like the Firewall Threat Defense or the Virtual ASA, which are also both on the AWS Marketplace. Security groups are stateful firewalls at layer 4, so if you just need layer 4 blocking, that's generally our recommendation. But if you need advanced security, that's generally where you would use more of an appliance-based firewall, like the CSR or the Firewall Threat Defense. There was also some performance questions around what type of performance to expect. Fan or someone else, would you like to cover that?
Yeah, so from the performance perspective, it really depends on which instance type you choose. So right now we support CSR running on T2 instance and C4 instance. So generally on T2 you can get more than 200 meg BPS with the IPsec encryption. And if you want to do really high throughput, probably you should go with the C4 instance. So the maximum throughput we can get on the C4 4x large. So it's HVM instance, and we can get up to 5 gig for the SAF, so that's the layer 3 routing without encryption, and 4.5 gig for the encryption packet. And we are working with our engineering team, so we are working on new data plan architecture, so more throughput, like 10 gigabytes per second, will be supposedly, like we are working to increase the throughput to 10 gigabytes per second, probably next year.
Okay, cool. Let's see here, just seeing some other questions come in. There was a question that just came in on if you're not allowed to use Lambda, how do you do the Transit VPC? And the answer is we've built a lot of the algorithms and the tags and the integrations into other services. So if you want to do that, you can rebuild it on EC2, so you can take some of the bulk of the code that's in the Python available in the Transit VPC cloud formation template. But you would need to do a bit of reworking to make it run on an instance as opposed to being event-driven. But effectively, the code would mostly stay the same. You just figure out how to get SQS to an instance and some other things. So it's mostly done, but it would be a bit of rework from a platform perspective. Let's see here. Get through some of the other questions here. There were some questions about AZ and the distances. So AZ stands for availability zone, which effectively for us is a data center or multiple data centers. And then the distance between availability zones is it's all within the same geographical area. So for instance, Northern Virginia is a geographical area. So data centers are typically going to be a couple milliseconds apart. There's not like a promise for that, because it depends on the region. So Japan's going to be a little bit different than the U.S., for instance, or maybe China. So we've got 14 different regions, so they all have their own. But effectively, expect less than a couple milliseconds between availability zones. Some of the Cisco guys, are there some other questions you guys want to go over? I'm still going through these questions. All right, so there's one here on if the VPC is fully redundant, why do we set up the Transit VPC? The Transit VPC is mostly for extending access to multiple VPCs. The VPC itself is available. You don't have to worry about that. But the Transit VPC, most of it is about, there's one rule for routing on AWS. If the packet comes from outside the VPC, the destination IP has to be an IP address in that VPC. So if you want a packet that comes from an external VPC to flow through a kind of essential security services VPC, and then go over your direct connect back on premise, well, the destination IP is outside the VPC, so we would normally drop that. By encapsulating that in a VPN connection to the CSR, it gets around that restriction, and then you can transitively pass that back on premise. So if you want to have one connection, maybe you only have one direct connect circuit. So one of the tricks with direct connect is that if you have a direct connect that is less than a 1 gig speed, so there's a 50, 100, 200, 300, 400, and 500 megabit per second connection, those connections can only be linked to one VPC. So if you're in that scenario and you've got 4 VPCs, you don't want to pay 4 different Direct Connect circuits, so you'll often bring in that circuit to one VPC and then want to fan out from there. So that's one of the kind of the killer use cases for the Transit VPC.
Yeah.
So there were some questions about port monitoring and span. So today there's no AWS span feature. The CSR supports ER span. So if there's traffic going through the CSR that you want to be copied off somewhere else, you can use ER span to do that today. Again, for the folks maybe that joined a little bit late, the slides will be available. This recording will be available later. And the Q&A that we're going over right now will be on here, but the Q&A that's on the side is not included.
Yep. So I think there are people asking about what's the support model for the Transit VPC. So I think this solution is a joint solution between Amazon and Cisco. So if you buy a license, so as I mentioned, if you buy a license at BYOL, so that's bring your own license, you will have full Cisco support for the CSR that's running in the Transit VPC. And for the cloud formation template, I think it's a open template, so you can modify those templates based on your requirement.
Okay. There were some questions about the performance impact of the ASR versus the CSR. That's going to be pretty wildly different because you're talking about a hardware platform with dedicated ASICs versus the CSR, which is a virtual appliance. So you're going to get much less performance on the virtual appliance than you would on a dedicated ASR. But luckily, hey, it's virtual, right? So you can spin up a lot in theory. So let's see here. Some other questions here. So there was a question that just came in around Cisco Firepower, Next-Gen IPS, and AWS and VPC. So right now you would either need to configure basically some routing policy, so either AWS routing tables or tunnels on a CSR to move traffic from a Cisco CSR over to the Firepower device, or if it's simpler, you may want to do your VPN termination. I think the Firepower device is still working on VPN. I'm not sure if it's there today or not. I'm less informed about that one. But you may end up with a different architecture where you use the Firepower device instead of the CSR if it's more of a firewall use case as opposed to more of a routing and VPN use case.
Yeah, just add on to that, I think we are also working on a deployment guide for the security appliance in the Transit VPC. So like the FTDV, the Firepower Threat Defense. So I'm working on deployment guide. So please stay tuned. We will publish that probably in the next month.
So there's also a question here that says, what do you recommend as a starting point to test functionality for your first VPC? That's what AWS loves. We love to make it easy to get started. So if you have an AWS account, or if you don't, you just need a credit card. There's a free tier, so you can, for instance, you can spin up a T2 Micro for an entire year for free. VPC comes as part of that, and there's a number of things we use to help people get started. There's a VPC wizard, which will help you create your basic VPC networking. There's also a couple of quick starts, so you can just do a Google search for AWS Quick Start, and it tells you, for instance, if you want to set up a MongoDB, that happens very quickly. So there's a lot of use cases. You can kind of spin it up for you, and it'll be in your account, so you have control over it. You can go and play with it. That's pretty cool. The CSR also has a free trial. So if you go out on the AWS Marketplace, you can go try out the CSR for free for, I believe it's 30 days or 15 days, if you want to correct me there. Okay, either way, which leads into another question we got, which is the pricing. So there's a number of different there's a number of different CSR licensing packages available on AWS for the CSR feature sets. And then you can buy those either what we call BYOL or bring your own license. So that means you go through the normal sales channel, whether you buy through a partner or your account manager. You can still buy a Cisco CSR through that model. Or as well through the marketplace, you can also pay for this hourly. So if you don't want to pay for a full year or a perpetual license, you can buy it from the marketplace, just pay for the hours you use it. So that's another way to procure that. And you can see the pricing for the AWS hourly on the Marketplace site. Let's see here.
Okay, Nick, just another comment on the license part. So if customer is buying the BYOL, so basically purchase license from Cisco, you'll have Cisco full support. But if you buy the hourly bill, so unfortunately you don't get Cisco tech support, but we will offer an open forum, so you can put your question in that forum, and we will monitor the thread.
Okay. There was a question about how many CSRs can be connected together. That's not an issue. So you can connect basically as many as you want because you get 10 gig interfaces on AWS. Let's see here.
Yeah, I think
there was a question about the TFR hub role, which is still, sorry, go ahead.
Yeah, so I see a lot of questions around like OTV, VXLAN. So CSR support those features because ASR support those layer 2 features. But with I think the challenge is on the public cloud side. So most of the public cloud provider like Amazon, they will block layer 2 packets like multicast and broadcast or the VLAN tag. So yeah, so the short answer is no, you cannot run OTV and VXLAN in the cloud, but you can run it on your private cloud. You can run it on public cloud actually.
There's a question about NetFlow support. It supports NetFlow as part of the ABC package, so NetFlow version 9. There's a question about CloudWatch. So you can support, you can enable CloudWatch for the CSR instance. Let's see here. More questions about the deck being shared. The deck will be shared. Recording will go out. Let's see here. If you guys have any more questions, bring them in because we're getting towards the end of questions here. I'm just reviewing some of the other ones to see if there's anything important in here. So this is a good question. There was a question about the CSR 1000V versus the native VPN that AWS provides. So when you create a VPC, you can go and create a VPN connection. The VPN connection for us runs off the virtual private gateway or the VGW. That virtual private gateway will create 2 VPN instances. So you'll get, if you have maybe a Cisco router, like an ASR or ASR or ISR at your data center or your branch, when you create a VPN connection to AWS, you'll have 2 tunnel endpoints. When you go and click on that Create VPN, it will give you a Cisco config that you can download and then paste or review, or if you want to go modify it, you can. That will give you VPN connectivity to those 2 endpoints in AWS. The good parts of this are that that's managed for you. So if one of those tunnel endpoints have an issue, or if you've got multiple routers and you're creating multiple tunnels, if you're running BGP, which I recommend on all those VPN tunnels, then we manage all the HA. So you don't have to worry about what happens if a router goes down, what happens if a link goes down, what happens if a tunnel goes down. All that's basically managed inside of AWS. As well, if you're advertising routes about your on-premise IP address structure, you can click a box inside of AWS to propagate those routes to all the subnets. And from the outbound connectivity from your instances back on-premise, if one of our instances fails, we can monitor that and we can change that route automatically. So that's kind of the good part. The things that people use the CSR for are higher throughput, so the CSR is going to get higher throughput than the native VPN. If you want more control and visibility, so if you want better flexibility with the BGP configuration, or if you want better control over maybe, for instance, the security features of the VPN, so different Diffie-Hellman groups or different IPsec throughput or different IPsec characteristics, you have full control of that. If you want better, for instance, SNMP monitoring or monitoring of the VPN, that's another use case for the CSR over the native AWS. As well as our VPN connectivity can't connect to each other. So if you want to connect 2 VPCs or 2 regions together, you can't use AWS native VPN to AWS native VPN. So you need something else on the other side of that, and so the Cisco CSR is a good use case for that.
I think I see a lot of attendees asking how do you do the HA. So if you are running the Transit VPC, it's natively HA. So to CSR, that will do the layer 3 ECMP to the WW on the spoke side. But if you are just using CSR in the VPC and you want to use that gateway, so actually you can put two CSR in the same VPC, and those two CSR will establish GRE tunnel, and you can run BFD over the GRE to detect the neighbor. If one of the CSR is down, the other surviving CSR will detect from a BFD down message, and then it will change the route table for those EC2 instance that's running in the VPC to point to the surviving CSR's interfaces. And it will make the API call to call the route change API. So that's how the HA worked. And I will post the HA deploy gun on the chat window so everybody can see that.
And this is a fun one, so it sounds like we've got a high school out there as well, interested in what's a good area of study. I think automation is core to a lot of these things. I think that understanding that programmability and APIs, especially around networking, is very, very important. More generally, cloud seems to be growing and not going anywhere. So, I speak somewhat biased on both of those, since I'm a huge network programmability and cloud advocate. But I think those are great places to start, as well as anything involved with machine learning. So there's some great reInvent sessions that happened last week, which are probably good for thinking more about that. So I think we're wrapping up on time here. I think we've answered most of the questions. Jerry, was there any closing notes that you wanted to talk about?
Just want to remind everybody we do have our polls open, so please feel free to complete those. We do appreciate your time today, and that's all I have for a wrap-up. Do we have anything else, Nick, for any other questions or anything? So
the slides and the recording will go out after this. So you'll get slides, you'll get the recording. And so thanks everyone for joining.